Council, Mr. Alamayo Taganu, the Mines and the Energy Minister, Your Excellency, Ambassadors, distinguished guests, ladies and gentlemen. This is the joint project implemented by Hope 2020 in the UDC, University of District of Columbia, Washington, D.C. It's a model project, and the solar wind hybrid power station for rural water supply project. Unfortunately, we invited His Excellency President Girma Waldagorgis. He couldn't reach here. He's around the reservoir. Our water reservoir is there, up. Therefore, let me turn to the Amharic, and the English version will be discussed by Professor Belatigo. እንኳን በሰላም መጣችሁ ላለኝ ሆፕ 2020 አገር በቀል ድርጅት ሲሆን ከዚህ በፊት በተለያየ የኦሮሚያ ክልሎች የውሃ የገጠሩን ህብረተሰብ የውሃ ተጠቃሚ ሲያደርግ ቆይቷል። ይሄንን ደግሞ ለመጀመሪያ ጊዜ በፀሐይና በንፋስ ኃይል በሚሰራ ፓወር ከጉድጓዱ ታች ነው እንዳጋጣሚ ሆኖ እንግዲህ አሁን ጊዜው የክረምት ነው። ሁላችሁም እንደማትቆጡን እናምናለን። በዚህ ኃይል ከጉድጓዱ ውሃ አውጥተን በዛ መንደር ውስጥ የውሃ ጋን አይታችሁ ከሆነ እዛ ውስጥ አለ። አሁን ስንመለስ እናያለን። እስከዛ ድረስ ከ2000 ህዝብ የሚበልጥ የውሃ ተጠቃሚ ንጹህ የመጠጥ ውሃ ተጠቃሚ አድርጓል። እንግዲህ ይሄ ፕሮጀክት ለማነሻ ይሁን እንጂ ለወደፊት ይሄንን ፕሮጀክት በከፍተኛ ሁኔታ በዚህ አገር ውስጥ እንጠቀማለን ብለን የራሳችን የሆነ ስትራቴጂ ቀርጸን እየተንቀሳቀስን ነው ያለነው። በአሁኑ ሰዓት እንደምናቀው ደግሞ የዚህ የኃይል ፍጆታ በጣም በአደገኛ ሁኔታ እየጨመረ ባለበት ሰዓት ላይ ምንም ነፃ በሆነ በተፈጥሮ ማልማት በሚል አላማ ተነስተን ዛሬ እነሆ እዚህ ላይ ደርሰናልና እንኳን በሰላም መጣችሁ እንዳለኝ አመሰግናለሁ።
Good morning. My name is Dr. Ben Latigo. I'm the Dean of the School of Engineering and Applied Sciences at the University of the District of Columbia. I'm here joined by my colleague, Dr. Samuel Leku. Dr. Leku is a native of Ethiopia. He is the chairman of the Department of Electrical Engineering at UDC. The project you see here is a joint project between Hope 2020, which is based in Addis Ababa, and the School of Engineering and Applied Sciences at UDC. It is an initiative that resulted from a request that His Excellency President Gama made when he visited Washington and he visited with our president of the university. And he wanted cooperation to alleviate problems of water development in rural parts of Ethiopia. It is a 3 to 4 year collaboration. The equipment you see here were donated to UDC by Southwest Wind in Arizona, and behind us the solar panels are donated by BP Solar in Frederick, Maryland. About 150 meters to the well, we have a ground force pump. The pump is located at 40 meters below the surface of the earth. We drilled a well to a depth of about 45 meters. That well, that pump now supplies power to the reservoir, which is 40 meters in height above the level of the well. The display shows the power that is currently available. The wind turbine needs about 3 to 4 meters per second wind in order to operate. And so, because it is not operating, the display you see is entirely from the solar panels. We have a similar system set up at our university. We are now collaborating with Addis Ababa University. The chair of electrical and computer engineering is with us, we will be monitoring the performance of this system online from Washington through an internet-based system. And Addis Ababa University will assist us to integrate the system. We have brought with us some hardware for instrumentation and data acquisition that should make it possible. We will also be installing on site a weather station that we will also monitor from Washington. So this will be an integrated research program for us. We are particularly interested in the effects of this program on the local community. The UN system is interested in something called the Human Development Index. So we are interested in finding out from the community. Join us, and we are grateful for the effort that Hope 2020 has put together to make this a success. Thank you.
Again, my name is Samuel Leku, Dr. Leku. I'm accompanying Dr. Latigo. I just wanted to add one comment to what Dr. Latigo just mentioned on the technical side of this. The uniqueness of this system is that it is, we have all, I'm sure most of you have seen that solar power is used all over the place, but solar power for which only the DC portion of it, the direct current of it only used is unique. This system here does not have any inverter. The inverter system is what makes most of the systems, the solar systems, unreliable, because these things have a lifespan of about 25 to 30 years. But when you put an inverter to them, the inverter breaks down very, very often. So people are turned off by that system because of just that. What you see here does not have any inverter. It just takes the direct current coming from the sun and go there, takes the wind and activate the pump. The uniqueness of the pump is it is also a DC pump. You'll be hard-pressed to find an AC pump that will work this way. So it's a DC pump, which also can work in AC. So it really has both. The only drawback, of course, is it works for relatively shallow wells, like this one, up to about 100 meters depth. So that's really the uniqueness of it, and we really would like to replicate this at various locations. This is really the ideal way of supplying water to any rural community, where there is sun, where there is wind. You don't need any inverter. Just place these panels and you're done. During the day, you fill up the reservoir. It takes about 3 days to empty this reservoir from the population of the village here. In March, when we were here for groundbreaking, we saw women and children going all the way down to the river down there carrying water. Now the water is right there for them. So it really makes a big difference for the livelihood of the community.
Thank you, Sam. Let me add that we designed specifically this system for this location. At a different location, we may have to design it differently. At this location, the well is fairly shallow. In many other parts of Ethiopia, you can go to depth of 150 or more meters. If we should encounter that, we would be forced to use an AC pump. So those are the type of things that we take into consideration. Yes.
Could I just ask, what are the investment costs for this kind of device?
Most of the equipment was donated, but some can run through some of the direct costs.
A quick rundown. The panels usually cost about $900 on the market. If you want to get this kind of panel, from $800 to $900 per panel. The wind turbine is about $7,000. The power pipes are not expensive. The connection lines, I would say about $1,000 for all the wiring. The pump is about $4,000 to $5,000, this particular pump. And then the installation, of course, the piping and building of the reservoir may be another $1,000 or $2,000. So I would venture to say that within about $60,000 to $70,000, you have a turnkey system that you can move around. By the way, this thing can be unmounted. It's sitting on a sleeve. There's a pole if it's some solar power.